Hello, my dear students. Welcome to IMS Gate Academy. A warm good evening to one and all. I hope all of you attended my Gate Score Booster sessions regarding digital circuit subject earlier. So I have taken 3 sessions regarding digital circuit subject. I hope all of you got the contents regarding digital circuit subject earlier. So those who couldn't attended those sessions, if any student not attended earlier, so you can attend those sessions in your free time later. So I am welcoming all of you for today's session. So today we are having the Gate Score Booster session on communication subject. This subject is common for 2 branches, ECE and instrumentation. Today we are having the first session and tomorrow we are having the second session. So all of you kindly share this video link with all of your friends so that they also will attend this session in live and they also will get benefited from this session. Yeah, good evening Jagdish. Good evening. So this subject communication is common for 2 branches, ECE and instrumentation. Here total we are having 7 chapters. So all the 7 chapters belongs to ECE branch with respect to gate exam point of view, except chapter 4 and chapter 7. Remaining chapters will be the part of the gate syllabus for instrumentation branch regarding the communication system subject. So in this particular session, we will focus regarding first 3 chapters, regarding amplitude modulation, regarding angle modulation, regarding AM and FM receivers. So in this particular session, we will discuss the questions related to these 3 chapters. In tomorrow's session, we will discuss the questions related to the remaining 4 chapters. Yes, Tushar, definitely. So in today's session, we will focus regarding first 3 chapters. In tomorrow's session, we will focus the questions related to the last 4 chapters, right? So this is the first question. This is the MSQ. That means either one option or more than one option can be correct. Okay. So first read the question carefully. The antenna current of an AM transmitter, they have given 9 ampere when only the carrier is transmitted, but it increases to 10.6 ampere when the carrier is modulated by a single sine wave. Choose the correct option or options. They have given 4 choices, among which 2 choices they have given regarding modulation index and 2 choices they have given regarding percentage of modulation efficiency. So all of you try this question. I will give some time for you to solve. Yeah, very good evening, Pratik. Very good evening. Yeah, other students also please try. I will disclose the correct answer in some time. Yes, very good Tushar. Yes, the correct answer for this question is you are having two choices, both option C and option D are correct. Yes, very good. See here, read the question carefully. They have mentioned the antenna current of an AM transmitter is 9 ampere when only carrier is transmitted. So that means this current is corresponding to IC, only the carrier current. Okay, and they have mentioned another current when the carrier is modulated by a sine wave. So that means this current is nothing but IT. Okay, when the carrier is modulated by the sine signal. Now, two choices you are having regarding modulation index, two choices you are having modulation efficiency. So first you have to calculate modulation index, after that you can calculate modulation efficiency. I hope all of you know this formula. IT equal to IC into square root of 1 plus mu square by 2. Okay, so here IT value, IC value they have given, you have to calculate mu. Okay, first let us rearrange this equation. Let us derive the mu formula first. So just perform squaring on both sides, and I am bringing IC to the left hand side. It will come to the denominator. So IT by IC whole square is equal to 1 plus mu square by 2. So this equation if you rearrange, you will get mu square by 2. Just bring 1 to the left hand side, it will become minus. So IT by IC whole square minus 1. Now from this equation you will get mu square equal to 2 times this overall factor, you will get IT by IC whole square minus 1. So we want only mu, so just bring square term to the right hand side, it will become under root. So then you will get 2 into IT by IC whole square minus 1. Okay, this 2 is you have to multiply with the overall term. Okay, now just substitute the given values. IT value they have given 10.6, IC value they have given 9 ampere. So substitute both the values. So you will get mu equal to square root of 2 into IT is nothing but 10.6 divided by IC is nothing but 9 whole square minus 1. So just do the simplification. You will get 2 into 1.3872 minus 1. So from here you will get 2 times 0.3872. So just do the simplification by using calculator. Yes, very good evening. Good evening, Mayank. You just do the calculation by using Calc, you will get 0.88. So this is the modulation index. Modulation index is 0.88. So that means if you observe one choice they have given 1.332, another choice they have given mu equal to 0.88. So you can eliminate option A. So you are having option C is correct. So now you can calculate the modulation efficiency. I hope all of you know the formula regarding modulation efficiency. Eta equal to mu square divided by 2 plus mu square. And here they are asking in terms of percentage. So eta in percentage is nothing but here right hand side you can multiply with 100. So here mu value we got 0.88. Just substitute that value. 2 plus 0.88 whole square into 100. So just do the simplification by using Calc. You will get 27.91. 27.91. 27.91 is the modulation efficiency in terms of percentage we got. Okay. So now the final answer for this question is you are having two choices, option C and option D. Yes, very good, Mayank. Yes. So this is a simple question based on the standard formulas regarding modulation index and modulation efficiency. I hope it is clear for everyone. This is a basic question. Now let us move on to the next question. This is the MSQ. So that means here also either one option or more than one option can be correct. So first read the question carefully and you can choose the correct options. Other students also please give a try. Whatever the options you are getting correct, you can mention in the chart. Yes, very good, Tushar. Yeah, Mayank, two options are correct. Okay, here they have mentioned if the peak amplitude of an AM signal, that means amplitude modulated signal, varies from 2 volts to 10 volts, then they are asking among the four choices which options are correct, you have to choose. So here two choices they have given regarding modulation index mu, and one choice they have given regarding total sideband power, and one choice they have given total power of AM wave. Okay, so that means for the given data, okay, first you have to calculate modulation index, then you can calculate AC carrier amplitude, and with the help of that you can calculate carrier power and then sideband power, total power, like that. Yes, okay, first let us derive regarding the modulation index and regarding carrier amplitude. I hope all of you know the standard equation regarding AM signal. Regarding AM signal, the standard equation I hope all of you know. S of t equal to AC into 1 plus mu into cos 2 pi Fm into t into cos 2 pi Fct. cos 2 pi fct. So this is the standard equation regarding AM signal in time domain. Okay, so now they have mentioned regarding the amplitude. Okay, so here if you consider the magnitude wise, okay, so cos value, maximum value will be 1. So here this envelope you will get, right? So just consider only this part, AC into 1 plus mu cos 2 pi fm into t. Okay, now if you observe here, you're having cos signal, right? Cos signal maximum value will be 1 and minimum value will be minus 1. Okay, so if you consider maximum value as 1, cos value, maximum value as 1, then regarding the peak amplitude, you will get maximum value, right? So for the timing, I am assuming Vmax equal to AC into 1 plus mu. When you have considered this entire cos signal as 1. Okay. Similarly, when you have considered cos signal value, minimum value is what? Minus 1. If you consider that one, then you will get minimum value. So these two values you will get in the positive side. Okay, regarding the amplitude. AC into 1 minus mu. Similarly, if you put minus, you will get in the downward like that. Okay. For the timing, we are focusing the positive side. Now, if you take the ratio of these two, just take the ratio of these two. Vmax by Vmin is equal to AC into 1 plus mu divided by AC into 1 minus mu. So here AC and AC will get cancelled. Now you are having like Vmax by Vmin is equal to 1 plus mu divided by 1 minus mu. So you can apply component and dividend rule. So from there you will get, okay, for the timing I am considering here whatever you are having numerator denominator, I am just performing subtraction operation in the numerator, and in the denominator I will perform addition of these two. Okay, Vmax minus Vmin divided by Vmax plus Vmin. Similarly, you can perform similar operation on the right hand side. You are having ratio of two numbers. Here left hand side we have performed subtraction operation. So in the same way you can perform subtraction operation. 1 plus mu minus of 1 minus mu. And here in the left hand side we have performed addition operation. Similarly, you can perform addition. 1 plus mu plus 1 minus mu. So here minus mu plus mu will get cancelled. Here plus 1 minus 1 will get cancelled. Okay. So what you are getting here? Plus mu minus of minus, that means plus. So 2 times mu you are getting in the numerator, and denominator you are having 1 plus 1 is nothing but 2. So that means 2 will get cancelled. Finally, you are getting modulation index is nothing but this entire equation. Yes, very good, Tushar. Okay, so that means mu is equal to Vmax minus Vmin divided by Vmax plus Vmin. You can remember the standard equation regarding modulation index. Okay, whenever they give the maximum value and minimum value regarding the AM wave, so directly you can substitute the values in this formula. Okay, just for understanding purpose, I have given the derivation. Even if you forget how to get this equation, for that sake I have given the derivation. Yes. Okay, so we got the modulation index. Now, in order to find AC, what you can do? Just you can give the numbering for this equation 1, and you can give the numbering to this equation as 2. And this one, say for example, equation number 3. Okay. Now just what you can do? Just by observing 1 and 2, just perform the addition of these two. If you perform addition of these two, mu term will get cancelled. Okay, so just perform the addition of equation 1 and 2. Then left hand side you will get Vmax plus Vmin. Left hand side you will get Vmax plus Vmin, and right hand side you are having AC into 1 plus mu plus AC into 1 minus mu. AC into 1 minus mu. So here mu times AC, here minus mu times AC, both will get cancelled. So AC plus AC, that is nothing but 2 times AC. So if you rearrange this one, you will get AC equal to Vmax plus Vmin, Vmax plus Vmin divided by 2. So directly you can remember these two formulas. Regarding modulation index, Vmax minus Vmin by Vmax plus Vmin. Regarding AC is nothing but average of those two. That's all. Average of those two. Okay. Now in the question they have given regarding Vmax, regarding Vmin. So if you substitute, you will get mu value. Similarly, if you substitute here, you will get AC value. Okay. So here in the question they have given maximum value as 10 volt, minimum value as 2 volts. So just substitute in the standard formulas. Just now we got mu equal to Vmax minus Vmin. That means 10 minus 2 divided by Vmax plus Vmin. That is 10 plus 2. So 10 minus 2 is 8. 10 plus 2 is 12. 4 2s are 8. 4 3s are 12. So 2 by 3, which is nothing but 0.666, like that you will get. So if you approximate up to 2 decimal places, you will get 0.67. Mu value you will get 0.67. Yes, Tushar. Yeah, you can easily remember those formulas. Yes. Okay. Now regarding AC value, AC is nothing but just average of these two. So that means 10 plus 2 divided by 2. 12 divided by 2, which is nothing but 6 volts. So we got the mu value and we got the AC value. Okay. Now let us calculate the powers. Let us calculate the powers. So carrier power is nothing but AC square by 2. So AC value just now we got 6. 6 square divided by 2. 6 square is nothing but 36. 36 divided by 2 is nothing but 18 watt. 18 watt. So regarding carrier power we calculated. Now regarding total sideband power, you will be having lower sideband and upper sideband. So together we will represent P suffix SB. So this power is nothing but regarding both the sidebands. So what is the formula? PC into mu square divided by 2. PC into mu square by 2. So just now we got PC value as 18. Mu square value, mu value we got 0.67. Square divided by 2. So here 9 times. Just do the simplification. You will get 4.04 watt. 4.04 watt you will get. Okay. Now the last parameter regarding total power transmitted, PT equal to carrier power plus sideband power. Carrier power we got 18 watt and sideband power we got 4.04. So just add these two, you will get 22.04. So now you just check all the options. So regarding modulation index, yes, option C is correct. So that means obviously option A is not correct. So regarding total sideband power, we got 4.04. Yes, option B is correct. And then regarding total power, 22.04. Yes, option D is correct. So in this way, first you can calculate the modulation index, then carrier power, then sideband power, and then total power. Okay. Otherwise, you can calculate carrier power and then total power. If you subtract carrier power from the total power, from there also you will get sideband power. So based on your convenience, you can calculate accordingly. Okay, right. I hope it is clear for everyone. Now let us move on to the next question. This is the NIT question. That means the answer will be a number. They are asking the transmitted power of the AM signal. They have given the AM signal, and for that they are asking the corresponding transmitted power. So all of you give it a try. Yeah, other students also please respond. Whatever the answer you are getting, you can mention in the chart. Yes, very good, very good. All of you are getting correct answer. Very good, Tushar, Rohit, Mayank. Yes, very good. 66.25 watts. Yes, very good. See, here they have given the equation of AM signal, but here if you observe, they are having one equation like this, but now you bring this equation into the standard form. Okay. Previously, we have given the standard equation of AM signal when only the carrier signal and one sine wave is there. But here you are having regarding modulating signal, you are having two frequencies. Okay. So just rearrange the given equation. Whatever the given equation is there regarding AM wave. So just what you can do, you can take 10 as common. Just take 10 as common. Then you will get 1 plus 4 by 10. 4 by 10 I am writing it as 0.4. Then cos of 8 pi into 10 power 3. 8 pi into 10 power 3 t. Then plus. I have taken 10 as common. So 7 by 10 is nothing but 0.7. 0.7 into cos of 2 pi into 10 power 40. 2 pi into 10 power 40. The overall signal is multiplied with cos signal. Cos of 2 pi into 10 power 60. Now just observe this equation with the standard equation of AM wave. Okay. The standard equation of AM wave we are having like this. S of t equal to AC into 1 plus. See, if you are having only one signal, then mu into cos 2 pi fm. But you are having two modulating signals. So we can consider it as mu 1 cos of 2 pi fm 1 t plus mu 2 cos of 2 pi fm 2 t, and overall signal we are multiplying with cos signal, that is regarding carrier signal, cos 2 pi fct. So previously regarding one modulating signal, that time we have discussed the standard signal of AM signal as AC into 1 plus mu into cos 2 pi fmt into cos 2 pi fct. From there we have derived the modulation index formula earlier, right? But here you are having two modulating signals. That's why we have to consider like mu 1 cos 2 pi fm1t, similarly mu 2 cos 2 pi fm2t. Okay. Now if you observe these two equations, from there we are getting AC equal to 10, AC equal to 10. Now mu 1 equal to 0.4, mu 1 equal to 0.4 and mu 2 equal to 0.7, mu 2 equal to 0.7. Now once if you are having AC, you can calculate the carrier power. Carrier power is nothing but TC equal to AC square by 2. So just substitute AC value as 10 here. So 10 square divided by 2. 10 square is nothing but 100. 100 by 2 is nothing but 50 watt. 50 watt. Now, if you are having only one mu, directly we can substitute in the standard formula. But here you are having two mu values. So from there, you can find the resultant mu. Okay. So I hope all of you know this formula. Mu 2 square is equal to mu 1 square plus mu 2 square. When you are having multiple modulation indexes, so that time in order to calculate the resultant modulation index, this is the standard formula. Okay. Here you are having only two modulation indexes. So like that, if you are having 3, you can add one more term. Okay. Right. So just substitute here 0.4 whole square plus 0.7 whole square. So 0.4 square is nothing but 0.16. 0.7 square is nothing but 0.49. So from here you will get 0.65. 0.65. This is the mu t square value. Okay. Now I hope all of you know this standard formula regarding, see here what you have to calculate, the transmitted power of the AM signal. Transmitted power of the AM signal. So that means PT equal to PC into 1 plus mu square by 2 if you are having only one modulation index, but here you are having more than one. So for that case, you can consider mu t square divided by 2. Tc into 1 plus mu t square by 2. So just now we got Pc value as 50. So just substitute here into 1 plus mu t square value we already got. Mu t square is nothing but 0.65. Okay, you no need to do once again squaring because we just now got mu t square value only. Directly you can substitute there and then divide by 2. So just do the simplification. From there you will get 66.25. 66.25 units are watts. So the answer for this question is 66.25. Yes, very good. All of you got the correct answer. So the next question is also NAT. So that means answer will be a number. So this question is regarding DSB-SC signal. So all of you try this question. Yeah, other students also please try, and whatever the answer you are getting, you can share in the chat. Yes, very good, Rohit, very good. Yeah, Tushar, you can cross check once. See here what they have mentioned, they have given the carrier signal C of t expression like this is modulated by a message signal M of t. M of t they have given like this. To generate a DSB-SC signal, then the power of DSB-SC signal will be. I hope all of you know regarding the DSB-SC signal. When you're having message signal and carrier signal, how we can get the DSB signal? What is the procedure? What we will do regarding these two signals? So all of you please respond. Whatever the two signals you are having, carrier signal and message signal, what we will do? What if we do? What kind of operation if you do? You will get DSB-SC signal. Yes, very good, Mayank, very good. What kind of operation we have to perform among these two signals? Yes, very good, Rohit. Yes, we have to multiply these two signals, carrier signal and message signal. If we multiply, then we will get DSB-SC signal. Okay. So regarding DSB-SC signal, S of t is nothing but the carrier signal and message signal, both we have to multiply. Okay. So whatever the expression they have given regarding carrier and message, so just substitute here. So regarding carrier, they have given 20 cos of 2 pi into 10 power 60. Okay. And regarding message signal, they have given 5 cos 8 pi into 10 power 3t. 20 cos 2 pi into 10 power 60, 5 cos 8 pi into 10 power 3t. Okay. Now 20 into 5 is nothing but 100. Now this cos signal I am writing as it is, cos of 2 pi into 10 power 60. Now this cos signal I am rearranging like this, cos of 2 pi into 4 into 10 power 3t. 4 into 10 power 3t. In general, we will be having 2 pi f format, okay, or omega t format. Omega is nothing but 2 pi. Here the frequency is 10 power 6. Here the frequency is 4 into 10 power 3. Right? Yes. So now, if you observe this equation, you are having cos A, cos B. Okay, I hope all of you know the standard formula regarding 2 cos A, cos B. Right? So you just multiply and divide with 2. 2 cos A, cos B. If you are having, I hope all of you know the standard formula regarding 2 cos A, cos B. Here 100 by 2 is nothing but 50. 2 cos A, cos B is nothing but cos sum plus cos difference. Cos sum plus cos difference. Cos of 2 pi you can take common from these two. Then here you are having 10 power 6 plus here 4 into 10 power 3. 4 into 10 power 3. Okay, 2 cos A, cos B is nothing but cos of sum of these two plus cos of difference of these two. 2 pi into 10 power 6 minus 4 into 10 power 3 into t. 2 cos A, cos B is nothing but cos sum plus cos difference. Now if you observe, see here 10 power 6 is nothing but the carrier frequency and 4 into 10 power 3 is nothing but message signal frequency. So what you are getting here? Here you are getting like FC plus FM and here you are getting FC minus FM. Now if you observe this particular equation, FC plus FM, see FC is the carrier frequency, FC plus FM is the what? Upper sideband and FC minus FM is the lower sideband, right? So that means here you are getting only the sidebands. You are getting both the sidebands, but whether you are getting any carrier component regarding FC component, do you have any signal? All of you please respond. Here you are getting upper sideband frequency component and here you are getting lower sideband frequency component regarding that magnitudes. Or whether we are getting any magnitude regarding the frequency component FC. No, right? So that's why this particular signal is what? DSB-SC. So that means we are having both the sidebands, but there is no carrier. Okay, carrier is suppressed here. If you observe AM signal, there we are having both the sidebands. Along with that, we are having carrier. Whereas in DSB-SC, we don't have the carrier frequency component related to that magnitude. We are having upper sideband frequency related, you are having magnitude. Similarly, lower sideband frequency related, you are having the magnitude. Okay, right. So that means this particular signal is nothing but DSB-SC. So now they are asking the power of this particular signal. See, in general, if you are having only like this format, okay. So this is the peak value or maximum value and you are having either cos or sine. So this is the maximum value or peak value. Okay. So in order to calculate the power, what we will do? VRMS square, right? We will calculate VRMS square divided by R, but here in the communication system regarding analog part, R value we will assume 1. Okay. So here VRMS square is nothing but Vm by root 2. Here VRMS square. Okay. Vm by root 2 whole square. And similarly, regarding the lower sideband, the same magnitude is there. So regarding that, RMS value will remain same. So square of the RMS is nothing but, here in this case you will get power. Okay, so both the signals power you have to add. Okay, since both the values are same, so just multiply with 2 of this quantity. 50 square is nothing but 2500. Root 2 whole square is nothing but 2. 2 will get cancelled. You will get 2500 units are watts. Units are watts. I hope you might have studied in your network theory subject also. Whenever you are having AC signals with different frequencies, okay, in order to calculate the equivalent AC power, right? So there you might have calculated RMS value and then you might have substituted in the formula like VRMS square divided by R. Okay, but here R value we will assume as 1. Okay, so the final answer for this question is 2500. 2500. Is it clear for everyone? All of you please respond. Yes, very good, very good. So now let us proceed to the next question. So this is the MCQ question. So that means only one option will be correct. Among the 4 choices, only one option will be correct. So read the question carefully and you can choose the correct answer. So this question is based on the concepts of 2 subjects. One concept is related to communication, another concept is regarding digital circuits, number system conversion. Yes, Mayank, in MSQ, either one option can be correct or more than one option can be correct. That means in few cases you may get all the 4 choices also correct. But there is a surprise in MSQ since we don't know really how many correct options are there. Okay, but generally for MSQ there is no negative marking, there is no partial marking also. Okay, this question is MCQ, only one option will be correct. This is a very interesting question. All of you give a try. This question is based on 2 subjects. One is communication, another one is digital circuits. See, read the question carefully. What they have mentioned, X and Y be the percentage of power saving in DSBSC and SSBSC respectively for modulation index mu equal to 1 by root 2. They are asking the value of 1000 times X plus Y. And if you observe the choices, they have given 2 choices in the decimal, 2 choices in the hexadecimal. Okay. Yeah, Tushar, you are almost come to the closer to the correct answer. Okay, we'll see, we'll discuss. So first let us calculate regarding X. What is X? X is nothing but percentage of power saving in DSBSC. Okay. See, in the DSBSC regarding percentage of power saving, as the name implies, double sideband suppressed carrier. So that means carrier power we have suppressed. That means that amount of power we have saved, right? So in the numerator you will get carrier power, and in the denominator whatever the AM signal is there, that signal when you have transmitted, that power you will get in the denominator. PC into 1 plus mu square by 2. PC into 1 plus mu square by 2. Here they are asking in terms of percentage, so you can multiply with 100. Here PC will get cancelled. So that means you are getting 1 by, just do the simplification, you will get 2 plus mu square. This denominator you will get 2 into 100. So if you rearrange this one, you will get 2 divided by 2 plus mu square into 100. 2 plus mu square into 100. And in the question what they have mentioned, regarding mu value they have given 1 by root 2. So that means mu square value will be 1 by 2. If you perform squaring on both sides, root and square will get cancelled. So you will get mu square value as 1 by 2. So you can substitute here. Mu square value is 1 by 2. Now 2 divided by, here in the denominator you will get 2 2s are 4 plus 1, that is 5 by 2 into 100. So this 2 will go into the numerator, then 2 2s are 4 divided by 5 into 100. So here 5 20 times, so 4 20s are 80. See here, this is the percentage of power saving. So that means here X value will get 80%, right? X equal to 80%. So if you write in the normal number, percentage is nothing but, you can write it as 1 by 100. So here 0 will get cancelled. 8 by 10 is nothing but 0.8. X value will be, in the normal value you will get 0.8. Okay, in terms of percentage we will say 80%, but in terms of the normal value you will get 0.8. I hope it is clear. Okay, if you done like this, then definitely you will get correct answer. Yeah, Tushar, you can try now. Now what is Y? Y is nothing but the percentage of power saving in SSBSC. The percentage of power saving in SSBSC. Okay. So Y is nothing but percentage of power saving in SSBSC. So as the name implies, in SSBSC, that means you are having only single sideband and carrier is suppressed. So that means 2 amounts of power you have saved. One is related to carrier power and other one is related to one sideband, either lower sideband or upper sideband, right? So PC into mu square divided by 4. See, in general, when you are transmitting the AM signal, you are having the total power as PC into 1 plus mu square by 2. This is the total power. See, regarding PC, yes, that power we have saved, and this PC into mu square by 2, this is the total sideband power. That means together, upper sideband and lower sideband together, you are having PC mu square by 2. But here, one of the sideband power we have saved, so that means you have to take half of this one, that is nothing but PC mu square by 2 divided by 2, which is nothing but PC mu square by 4. Okay, right. PC mu square by 4. Now, From the numerator you can take PC as common, from the denominator you can take PC as common, then PC will get cancelled. Then you will get 1 plus mu square divided by 4 divided by 1 plus mu square by 2. Here also they are asking in terms of percentage, so you can multiply with 100. Now just take the LCM. So numerator you will get 4 plus mu square divided by 4, and here regarding the denominator you will get 2 plus mu square by 2, that 2 I am writing in the numerator, into 100. Okay, 2 times, 250 times. Okay, right. Then you will get 4 plus mu square divided by 2 plus mu square into 50. Now here also just substitute the given mu value. Mu value they have given 1 by root 2, so that means mu square is nothing but 2. Mu square is nothing but 2. Sorry, mu square is nothing but 1 by 2. Mu value they have given 1 by root 2, so mu square is nothing but 1 by 2. 4 plus 1 by 2 divided by 2 plus 1 by 2 into 50. So just do the calculation. Here numerator you will get 2 4s 8 plus 1, that is 9 by 2, and in the denominator you will get 2 2s 4 plus 1, 5 divided by 2 into 50. So here 2 2 will get cancelled, 5 10 times. So that means you will get 90%. So if you write in the normal value, you will get y equal to 90%, is nothing but 1 by 100. Here also 0 will get cancelled. 9 by 10 is nothing but 0.9. So regarding x we got 0.8. Regarding y we got 0.9. I hope it is clear for up to this point for everyone. So all of you please respond. Up to this point, is it clear or not? If you are having any doubt, you can ask regarding the calculation of x and calculation of y. Yes, very good, very good. So x value we got 0.8 and y value we got 0.9. So now let us calculate 1000 times x plus y. 1000 times x value we got 0.8 and y value we got 0.9. So this value is nothing but 1000 into 0.8 plus 0.9. You will get okay, you will get 1.7, right? Okay, so you can do the correction here. Sorry, you can just make it as 100. Just make it as 100. Okay, just do some small correction here. It is a typo mistake. So just make it as 100 into x plus y. In the question also you can do the correction. Here just consider it as the 100 into x plus y. Okay, 100 into 1.7. So that means you will get 170. 170. 170 is the decimal number. Now all of you convert it. Yes, very good, Tushar, very good. Yeah, that is a typo mistake. So please do the correction. Instead of 1000, you can consider it as 100. Now all of you just try to convert this number into the hexadecimal. So I will show the options. Here these are the 4 choices you are having. So you got 100 times x plus y as 170. 170 base 10. So 170 base 10, here these two are not matching. So you can eliminate these 2 choices. Here you are having base 16. So you can convert into base 16. Yes, very good Tushar, very good, correct. See, we got 170 base 10. Now we have to convert this one into base 16. Now we have to convert this one into base 16. So in order to get the corresponding hexadecimal digits, you have to perform repeated division with 16. Okay. So 16 tens are 160. Remainder you will get 10. 10 is nothing but in hexadecimal A. 16 zeros are 0. Remainder is 10. 10 is nothing but A. Okay. So that means you are getting two hexadecimal digits. Both the values are A only. AA base 16. AA base 16. So here this value is 100, it's not 1000, sorry. Okay, so just observe here, after calculating 100 times x plus y, you got the value as 170, 170. So just by looking at the choices, here two choices you're having decimal, one value is 100, other value is 270, both are not equal, so you can eliminate these two. And here actually you're having 170 as the decimal, but they have given 170 as the hexadecimal. Obviously these two are not same, you can eliminate. So obviously the leftover option is option D. So in this way you can see, you can come to the right answer by finding the correct procedure, whatever the standard method is there, by converting the decimal into hexadecimal, or otherwise just after getting this number, just by observing the choices. Okay, this question is MCQ, as the name implies, choice already is there, right? So just by observing the choices, you can eliminate straight away three choices. Okay, because 170 already you are getting in decimal, and in the decimal number system they have given two different numbers which are not equivalent to this number, right? So straight away you can eliminate these two. And 170 in base 10, 170 base 16, obviously these two are not equal, so you can eliminate option B also. In this process, if you are able to eliminate straight away three options, obviously the leftover option will be correct. Okay, so in this way, in the GATE exam, okay, so based on the convenience, sometimes with the help of standard method, conventional approach, you can come to the right answer, and other method is by eliminating the options. Okay, after solving the question up to some stage, after that, instead of proceeding in the conventional approach directly, so just observe the choices. Okay, just have a glance, from there you will get the clue. If you are able to eliminate straight away three options, then you can save the time, in order to choose the correct option. See, ultimately in the GATE exam you have to attempt the questions correctly, and you have to attempt the questions in less time. Both are important, right? So it's a matter of time and accuracy, both are important. Okay, so in this way, if you are able to solve some questions in the initial 1 hour time in less time, okay, if you are strong on whichever subjects, if you are strong, if you are able to solve those questions in less time, definitely you can spare whatever the time you have saved. Okay, you can spare for the some questions definitely will take more time for solving. So without having any panic or tension, you can solve those questions in relaxed manner, and definitely you will get the correct answer. Okay, right. So all of you please respond whether this question is clear for everyone. How many of you liked this question? All of you please respond. Yes, very good, very good. Now let us move on to the next question. This question is NAT, that means answer will be a number. So just read the question carefully, and then you can mention your answer in the chart. So this question is also based on two concepts. One concept is from communication, another concept is from digital circuits regarding number system conversion. So all of you give a try. This is also interesting question. All of you give a try. Others also please try and share your answer in the chat. Yeah, Tushar, in the decimal you will get 2.36. You're almost closer to the correct answer. See here, first read the question carefully. They have mentioned 10 signals you're having, and each one is band limited to 5 kHz. So that means for each signal, the maximum frequency allowed is 5 kHz only. Okay. So that means this particular frequency, you can say it is the maximum frequency of the signal FM. Okay. And like that, you're having 10 signals. Like that, you're having 10 signals. And all these 10 signals are transmitted through a channel using frequency division multiplexing. That means FDM. And they have mentioned the God band is there 2 kHz. God band means, so between two spectrums, two frequency spectrums, we will keep some band of frequencies. There we won't give any particular, whatever the signal you're having, we will keep that one like buffer. Okay. So just to avoid any interference. Okay. And let P be the bandwidth of the multiplexer signal if all the modulators used are of AM. If all the modulators used are of AM. Similarly, let Q be the bandwidth of the multiplexer signal if all the modulators used are of DSBSC, and let R be the bandwidth of the multiplexer signal if all the modulators used are of SSBSC. Okay. So here this question, if you observe, they have used the concepts of AM, DSBSC and SSBSC. Okay. And they have used the concept of FDM. And now regarding this particular value, Q divided by P minus R, they have assumed this one as Z base 5. Then the value of Z they are asking. That means whatever the number here you are getting, you have to convert into base 5 number. Base 5 number. Okay. So first let us see case by case. See, if you consider the modulator as AM. Okay. See, in the AM signal, what you are having? You are having carrier signal, you are having upper sideband and you are having lower sideband. That means if you are using AM signal, okay, then bandwidth what you will get if you are having a particular signal. Okay. Since you are having the lower sideband, upper sideband and carrier frequency. Yes. Yeah, thank you. Thank you, Tushar. Thank you. So all of you please respond. Regarding AM signal, what is the bandwidth you will get? When you're having a particular signal, if that signal frequency is FM, okay, when you're using AM, you will get upper sideband, you will get lower sideband and you will be having the carrier also. So regarding bandwidth, what you will get? For generalized case, forget about this value 5K, but for generalized case, if you are using AM, what is the bandwidth? Yes, very good Rohit, very good. It is 2 FM. Just for the timing, you consider only one signal. Okay. See, upper sideband is what? Just for easy understanding, I am representing here. See, upper sideband frequency is what? FC plus FM. Okay, this is the upper sideband frequency component. Minus lower sideband frequency component is what? FC minus FM. FC minus FM. If you subtract lower frequency component from the higher frequency component, so that range of frequencies is nothing but bandwidth. Okay. So here minus FC plus FC will get cancelled. Minus of minus is nothing but plus. So FM plus FM is nothing but 2FM. FM plus FM is nothing but 2FM. Yes, very good. Very good, Tushar, Rohit. Yes. Now, similarly, can you tell regarding DSBSC signal? Regarding DSBSC signal, what is the bandwidth? What is the bandwidth? See, we will analyze this entire question case by case so that you can understand clearly and we will get the final answer. Okay, right. So here also if you observe, here you are having double sideband. That means both upper sideband you are having, lower sideband you are having, but in between carrier frequency will be there. That is not there. Here carrier is suppressed, but whether carrier is present or not, irrespective of that, here upper sideband means this is the frequency component, lower sideband means this is the frequency component. Obviously range of frequencies is nothing but bandwidth. That means here also you will get the same thing, 2 FM only, 2 FM only, right? Okay. So next, regarding SSBSC signal, if you consider SSBSC signal, what is the bandwidth you are going to get? Yes, in this case you will get FM only, FM only, because here say for example if you are considering upper sideband as FC plus FM, okay, see that single band could be either lower frequency component or it can be higher frequency component. For the timing if you assume FC plus FM, okay, is the higher frequency component and reference is what? Carrier frequency. From carrier frequency upper towards right hand side, right? So that means FC will get cancelled. Or if you consider lower sideband FC minus FM, okay, this is the lower frequency component, this is the lower frequency component. Obviously higher frequency component will be FC, okay, higher frequency component minus lower, okay, here FC will get cancelled, minus of minus is nothing but plus FM, okay, either you consider this case or this case, okay, finally you will get FM, okay. Or in simple words, if you are having only single band, that means whatever the maximum frequency of the signal you are having, that is the bandwidth, okay. If you are having both the sidebands, then obviously what you have to do, you have to multiply with 2 whatever the message signal frequency you are having, okay. If you are having more than one message signal frequencies, then among those frequencies, whichever is the maximum, that one we will consider. But in this case, since all the signals are having the same frequency, obviously the maximum frequency will remain same. I hope up to this point it is clear for everyone, okay. Regarding AM and DSBSC, the bandwidth is 2 times FM, whereas for SSBSC the bandwidth is FM, okay. Now let us come back to this question. Here what they have mentioned, you are having, see, like this signals you are having 10 signals, okay. For the timing just assume there is no God band, okay. Then what will happen? Okay, I will explain in the next slide. So regarding AM and DSBSC, okay, bandwidth, okay, see, for a particular signal 2 times FM, like that you are having 10 signals, okay, 10 signals. So this is related to 10 signals. 10 signals if there is no God band, okay. So 10 signals you are having, and for each signal the bandwidth is 2 times FM, okay. So that means 10 into 2 is nothing but 20, into FM they have given 5 kilohertz, they have given, okay. So that means 100 kilohertz bandwidth we require, provided if there is no God band, okay. But in the question what they have mentioned, there is a God band between 2 spectrums, right? See, if you observe here, total 10 signals you are having, that means from between each 2 signals, whatever the consecutive 2 signals you are having, among that between you are having God band, okay. So that means if you are having 10 signals, like this, 1 2 3 4 5 6 7 8 9 10, okay, if you are having 10 signals like this spectrum, okay, how many God bands we require? Yes, we require 9 only, yes or no? See, between these two God band, like that, how many we require? We require only 9, yes or no? Yes, we require only 9 God bands, okay. Generally students will do mistake here only, okay. Since they have mentioned 10 signals, they will consider 10 times God band. No, not required, okay. Because God band means what? Between 2 signals, there is the some buffer range of frequencies that we are not using for the signal, that we are keeping as a buffer, okay, just to avoid the interference. Okay, so like that you're having 9 God bands, and for each God band they have allocated 2 kilohertz, 2 kilohertz. Okay, right. So now 10 signals if there is the God band, 10 signals are there if there is the God band, if there is God band. Okay, now in this case what we have to do, whatever the earlier bandwidth we got, I am considering that one as it is. Now in addition to that 9 times God band we have to consider. God band they have given 2 kilohertz, so that means what you will get, 100 plus 18, 100 kilohertz plus 18 kilohertz, so that means 118 kilohertz you will get, 118 kilohertz. So regarding AM DSBSC, since the bandwidth is same, whatever the final calculation we are getting, the final answer will remain same for both AM and DSBSC regarding the bandwidth. So that means this value is same for P and Q according to the question, according to the question. Okay, so just observe, according to the question what they have mentioned, let P be the bandwidth of the multiplex signal if all the modulators used are of AM. Similarly, Q be the bandwidth of the multiplex signal if all the modulators used are of DSBSC. So now with this understanding, all of you just give a try regarding SSBSC signal. Regarding SSBSC signal, if there is no God band, what is the answer? If there is a God band, what is the answer? All of you give a try. Yes, very good, Tushar, very good. So all of you give a try regarding SSBSC case. If there is no God band, how much bandwidth we require? If there is a God band, how much bandwidth we require? Yes, very good, Tushar, very good. Yes, correct, excellent. See, in the SSBSC what we have mentioned, if you are having single signal, then FM is the bandwidth. Okay, right. Like that you are having 10 signals, like that you are having 10 signals, so that means bandwidth you have to just multiply with 10, 10 into FM. FM they have mentioned 5 kilohertz, 5 kilohertz, so that means 50 kilohertz, 50 kilohertz. So this is the bandwidth you require if you are not providing any God band. That means if there is no separation between any two signals in the spectrum, frequency spectrum, so then 50 kilohertz are sufficient. But in the question they have mentioned God band is 2 kilohertz, right? Now you have to consider. So here final, this whatever the God band earlier you have considered, the resultant value will remain same. So that means 9 into 2 is nothing but 18 kilohertz. So this value we have to add, that's all. Okay, right. So bandwidth here in this case we will get 50 kilohertz, 50 kilohertz plus 18 kilohertz, 18 kilohertz. So 50 plus 18 is nothing but 68, 68 kilohertz. So according to the question, this is nothing but your R. Okay. See, in the question they have mentioned R is nothing but the bandwidth of the multiplex signal if all the modulators used are of SSBSC, right? So up to now we calculated regarding P and Q, PQ values are same, and regarding R we got, but now they are asking this one, they are asking this one, Q by P minus R, Q by P minus R. Okay, so just I am doing the calculation here. Q by P minus R we have to do. So Q value is 118 kilohertz, and P value also same 118 kilohertz, minus R value is nothing but 68 kilohertz. So you can take kilo as common, so then kilo will get cancelled. 118 divided by 118 minus 68 is nothing but 50. So just to make the calculation simpler without using pen and paper, okay, what you can do, just multiply and divide with 2. Okay, so 250s are nothing but what? 100, 100. Now multiply 2 with this one, what you will get? 236 you will get. 236 divided by 100 is nothing but 2.36. This is what? Your decimal number. 2.36 is the decimal number. Yes, very good, Tushar, very good. Yes. So Q by P minus R, if they ask in terms of the decimal, so definitely 2.36, that is the correct answer. But here in the question, what they have mentioned, that one they have equated to Z base 5. That means whatever the number you have got, you have to convert into base 5 number. Okay. So we got 2.36 Z base 5 is equal to 2.36 base 10. So now you are having integer part, you are having fractional part. Okay. So whenever you want to convert decimal number, integer part into base 5, what is the procedure? All of you please respond. If you are having only integer part, if you want to convert the decimal number, integer part into the corresponding base 5, what is the procedure we have to do? Whether repeated division with 5 or repeated multiplication with 5, which is the procedure? Which procedure we will follow? I am talking only for integer part. Yes, very good, Rohit. Division. It is very simple. See, even if you are having any confusion in the GATE exam also, whether you have to do repeated division or repeated multiplication, the procedure, okay, whether whatever the thought process there, whether it is correct or not, you can easily guess. See, here you consider any integer value, okay, if you want to convert into base 5, see, if you want to convert into base 5, okay, see, if you consider any integer, if you are performing division, okay, you consider any integer number, if you divide that number with 5, what are the possible remainders you will expect? If you are dividing any number with 5, what are the possible remainders you will get? Divide any integer with 5. Then what are the possible remainders you will get? Yes, very good, Rohit, very good. Yes. Yeah, good evening, Shashi. Yes, very good, Tushar. Sorry, very good, Tushar, Rohit. Yes, very good. Whenever you are dividing any integer with 5, obviously you may get either 0 or 1 or 2 or 3 or 4. So that means 0 to 4 you are getting. 0 to 4 if you are getting, so that means for a particular digit, if you are able to represent only these 5 possible values, 0 to 4, that means obviously what? These digits correspond to what? Base 5 number system. So in that way also, if you are having any confusion, whether it is repeated division or repeated multiplication, in this way you can cross check. Okay. So here you are having integer part 2. So if you want to convert to base 10 into the corresponding base 5, so just now we have mentioned that you have to perform repeated division with the corresponding base. Okay. So here 5 zeros are 0, remainder is 2. So the moment if you are getting quotient as 0, you can stop the process. So obviously here in this case, 2 base 10 is same as 2 base 5. Both are same. Okay. Now exactly opposite procedure you have to follow for fractional part. So here regarding fractional part, you are having 0.36. Now we want to convert this one into base 5. Okay. Here we have done repeated division. Now here we will do repeated multiplication with the corresponding base. 0.36 into 5. 5 6 are 30, 0 and 3. 5 3s are 15. 15 plus 3 is 18. Okay. So here you are getting 1.8. See, in this case, whenever you are performing repeated division, okay, with the corresponding base, whatever the remainders we are getting, we will consider. Here, while you are performing repeated multiplication, whatever the integers you are getting to the left of the radix point, that integers we have to consider. here you got integer as 1. Just take that integer 1. The moment if you are taking 1, here the digit value will be 0. So now the resultant value you are having 0.80. So continue this process. Okay. So 0.8 into 5 is nothing but 4.00. So in this case, to the left of the radix, you are having integer as 4. Just take this integer 4. The moment if you are taking integer as 4, here digit value will become 0. Okay. So in this case, you are getting all the digits are zeros, you can stop the process. Just like here, the moment if you are getting quotient as 0, you can stop the process. Similarly, while you are performing repetitive multiplication with the corresponding base, if you are getting all the digits are zeros, you can stop the process. Or based on the given choices, if you are unable to get all the zeros after performing repetitive multiplication for few iterations, then based on the given choices, we will perform this kind of repetitive multiplication for that many number of iterations accordingly. Yeah, good evening Nikhil, good evening. Okay, so in this case, see here in the integer part, whatever the remainders you are getting, we will consider in the reverse order, whereas here whatever the integers you are getting, you have to place after the radix point in the same order. Okay, after the radix point we have to place in the normal order, same order. Okay, so in this case we are getting 0.14, which is belongs to base 5 number system, which is nothing but here regarding 0.36. So if you want, you can write that 0 like this. Okay, 0.36 base 10 is nothing but 0.14 base 5. So 2 plus 0.36 is nothing but 2.36. In the same way, regarding base 5 numbers, integer part and fraction part, if you add, what you are going to get? So we got Z base 5, which is nothing but 2.36 base 10. So that one, when you have converted, what you are going to get? What you are going to get? You will get 2.14. 2.14 in base 5 number system. So that means Z is nothing but 2.14. 2.14. Okay. So the final answer for this question is 2.14. See, in the GATE exam, sometimes they will ask the questions based on the concepts belongs to the same subject. Okay, sometimes they will frame the questions, the concepts belong to different subjects, right? So that time don't get panic. Okay, just recall the basics. If you are able to recall the basics, okay, and if you are strong on the basics of each and every subject, then definitely you will answer those kind of questions whenever the questions you are getting the multi-concept and which belongs to the multi-subject. Okay, see, if you are good at only one subject and if you are not good at another subject, then what will happen? You may solve that question partially, but you cannot attempt that question because you are not having the knowledge of other subject, right? So that's why it's very important that you should be fundamentally strong on the basics of each and every subject. Okay, don't leave any subject. Okay, there is no question of it is a tough subject or it is an easy subject. Okay, see, as long as you don't know about the concepts, you may feel that the subject is tough, but if you are having the awareness of each and every concept, what the functionality or what is the operation or etc., everything, if you know crystal clear, then that subject is no more tough, right? So I hope all of you please be strong on the basics of each and every subject. Then definitely in the GATE exam, whenever you're having the questions related to the multi-subject, definitely you can attempt those questions and you will get the correct answer, right? How many of you like this question? All of you please respond. All of you please respond. How many of you like this question? Yes, very good, Tushar, very good. I hope all of you are liking these questions, right? Yes, very good. Now let us proceed to the next question. So up to now, whatever the questions we have discussed, that is related to the first chapter. Yes, thank you Rohit, thank you Tushar. Yes, all of you kindly share this video link with all of your friends so that they also will get benefited from these sessions, right? Yes. So up to now, whatever the questions we have discussed, these questions related to the first chapter, that is regarding amplitude modulation, DSBSc, SSBSc, etc. Okay.